Hello everyone, my name is Tristan and on this video I'm going to talk about gravity car. Now you may not know what a gravity car is, but don't worry, we'll get into that in just a second. In this video I'm going to talk about the effect that difference in mass of the load of the pulley in gravity car gave to its maximum distance. We'll run a gravity car with two different mass load to see which one goes further and why can it reach such distance. So right here in my table is my model of gravity car that I have made. It's actually made from quite simple materials you can find nearby in your house. So first of all, I'm going to explain how gravity car works. So right here in the top, here's a pulley and the load of the mass. Here I use a cream pot of a body cream that has been removed and fill it with sand and stones. This one is 200 grams and connect it with a mattress thread right here over the pulley and connect it with the front axle of the gravity car. So as you can see right here, the gravity car is not moving because I have put a bag right here to stop the gravity car from moving, because it's actually on my table right now, and if I remove the bag it'll drop down to the floor and broke the whole thing. We don't want that to happen. And right here in the middle there's a gap or a hole, I should say. This is the place where the mass of the pulley will drop down and eventually drop down to the floor, and when the length of the mass thread has been completely used, it will detach from the front axle and the mass will drop down to the floor while the car continue on moving until it stops. So for the dimension of this gravity car, it's 35 centimeters in length, 15 centimeters wide, and for the wheels right here I use some old PlayStation 2 CDs and bottle caps to hold it with the axle. And for the both front and the back axle, as well as the supporting rods to hold the pulley up here, I use one of those huge wooden rods. These are used to make smoked fish. And for the pulley itself, I used Lego tires from one of my old Lego toys and scavenged them. Used two sets of them, strap them together, and here I put a small piece of cardboard on either side to stop it from moving to left to the right. And for the middle part here, connecting it with the supporting rods, I use the body of a brush. Just use the body of it, and the brush itself has been removed. So to sum it up, gravity car is a model of a toy that can move by only using the power of gravity. When the mass of the load is still hanging up here, it has a potential energy, but when it moves down, it converts those energy into kinetic energy, and the rotating axle caused by the mass dropping down is what makes the car moves forward. That's the basic explanation of how gravity car works. And oh yeah, this pulley is 48 centimeters in height. Let's get to some more stuff now. Okay, so after we got the recordings and the videos from our experiments, now it's time for us to analyze the video. For analyzing the video, I use the video editor app from Windows, from Photos. This application is quite useful to analyze the video, and I believe every one of you must have this application built into your computer. So with this application, we can see every frame of the video to determine when the gravity car reach several distances. So you can see right here that I have gathered every data of the length and the time when the gravity car reached certain distances. So here's the time when it reached the first starting line, and when it reached 0.3 meters or 30 centimeters, it's 3.63 seconds. And this data is for the gravity car with the mass of the polyload is 200 grams. I measured it by every 30 centimeters. The mass of the car itself without any of the load attached to the pulley is 0.2 kilograms. The load mass for this is 200 grams, so that will be 0.2 kilograms, and the total mass will be 0.4 kilograms. So by the measurements I've done with the first take on the gravity car experiment with the 200 grams mass of pulley load, it traveled the maximum distance of 10.59 meters and achieved a maximum velocity of 0.75. How do you measure the velocity? Well, I made another table of the time here, and for the time here initially I reduced the time with the first time data when the wheel reaches the starting point. So 1.93 minus 1.93, you get 0, and you do the same for the other data. So it's 3.63 minus 1.93, you get 1.7. And to get the velocity, you simply need to divide some of these data. To get the velocity, you will have to for example 0.6 minus 0.3 divided by 3.1 minus 1.7, and then we'll get the data of velocity is this one right here. And using the time and velocity here, I made a graph when the gravity car is on the acceleration phase. So you can see here the velocity is gradually building up, and it's not constantly being upwards. That may be caused because friction on the floor being not really leveled, and many other factors. But you can see here this is the period, the graphic of period of time when the gravity car is on the acceleration phase, and this right here, when it reached the highest point, it achieved a maximum velocity of 9.75 meters per second. And also I managed to find out the distance and time when the pulley load dropped from the gravity car right here. It's 7.8 meters and at the time of 19.23 seconds. And for this graph down here, it's the phase when the gravity car is on a deceleration phase. So you can see here that the velocity drops down with the time until it eventually stops. And for the graph right here is the graph for the distance traveled of the gravity car relative to its time. And to find out the acceleration of the gravity car on this one, I used the scatter graphic and then used the trend line and show the equation, and you get this equation. Take the coefficient in front of the x, that's the acceleration. Do it the same for the deceleration graph, and then you get the deceleration value right here. So for the formula to calculate this, we use this, where the velocity is initial velocity added by acceleration and multiplied by the time. So for the velocity during the acceleration phases, we got this amount right here, and for the velocity during the deceleration phase, we get this amount right here. And to calculate the distance, we use this formula right here. We use the initial velocity multiplied by the time, added it with half times the deceleration, because we're only calculating the deceleration phase, because I found out that the pulley load dropped on the same distance, 7.8 meters, for both the 200 grams mass of pulley load and the 140 grams mass of pulley load. So you can see it here that the pulley load dropped on the same distance at 7.8 meters, just with a different time needed to reach that distance. So we only need to calculate the distance on the deceleration phase. And you put in the formula, put in all the numbers needed, and you got the distance here, and added it with the total distance, and when the pulley dropped 7.8 plus the distance you got from this formula right here, and you get the total distance of the gravity car traveled. And do it the same for the other one. That the greater the mass of the pulley load in a gravity car will result in a greater acceleration of the gravity car when it moves. So that greater acceleration will also cause the gravity car to travel longer distances. So if you want to make your gravity car travel more distance or longer, then I recommend you to use a heavier load in your pulley load, so it will create a greater acceleration that will eventually cause it to travel further. So I guess that's all I can say for this video. Thank you for watching, and I hope that this video could inspire people out there to find out more ways on how to make a gravity car even better.